Welcome to our channel, my dear students. Today we are going to talk about the previous year, that is last 10 years CBSE board chemistry questions part 34, in which we are going to discuss about the aldehydes, ketones and carboxylic acid chapter. So here the question number 1 is, write the main product of the following reaction. That was asked in the year of 2015. Let's check. As we know the trick PCl5. If PCl5 will come and approach, so we already learn about a lot of things regarding this. Say for example, if PCl5 will come, so we have to separate these into both. That is Cl, here also one Cl, remaining PCl3. That is what I'll be getting the product like this. That is CH3, C double band O, Cl along with POCl3 with HCl. Am I right? I think so. You learned very well about this trick. I think so. You know very well about this trick. Please remember it. And next question is, explain about the decarboxylation reaction. The decarboxylation reaction in the sense, say for example, if I'm taking COONA, so sodium salt of acid I'll be taken. So this will be reacted in presence of sodium hydroxide NaOH along with calcium oxide. That time I'll be getting the product, that is RH, along with that CO2, carbon dioxide, is getting eliminated. Okay, are you able to understand, student? This is nothing but the decarboxylation reaction. That is here the formation of carboxylate into ion into what is that, alkane. That's the ultimate product. And next one is the convert the following. This is a benzoic acid to benzaldehyde. So we have to convert this benzoic acid into benzaldehyde. It's a very simple one, I think so. So here we have to react this benzoic acid, that is COOH. If it is react with either SOCl2, if it is reacting with SOCl2, as we know that previous trick, that is nothing but here the splitting of this thing, Cl and one more SO is there. So here if I want to write the product, so I will be going to write the product like this. That is C double band O, Cl is there, along with one SO2 is there, one HCl molecule is there. Okay, so if I got this product, I'll be going to react in presence of palladium hydrogen in presence of barium sulfate. So there is nothing but the Rosenman reduction. So if you do that Rosenman reduction, so I'll be getting the product. My ultimate product is benzaldehyde. I think so you remembered well about this mechanism, why we used barium sulfate. So here, which will be acting as a poison here. So if you don't know about this concept, please go and watch my previous video in Rosenman reduction also, or previous year questions. And next one is, distinguish the phenol and benzoic acid using a chemical test. So you just see, look at this question. This was asked in there many years, that is 2010, 2012, All India Board 2014 and Delhi Board 2013. So they are asking in well number of times, so that much of importance here. So here we have to write the structure of benzoic acid as well as the phenol. So then only, because both are acidic, but the thing is, we have to identify which one is giving these kind of reactions. Say for example, if this is the benzoic acid which is having, it's nothing but a carboxylic acid, but here also it's acidic nature, but it is having very less acidic when compared to carboxylic acid. So that if I add, what is that, if you want to get a brisk effervescence, then what you have to add? So we have to add sodium bicarbonate. If you add sodium bicarbonate, that carbon dioxide will comes out. But in the case of only benzoic acid, only the carbon dioxide will comes out. In phenol doesn't respond. That is the distinguish the test for phenol as well as benzoic acid. And next one is a benzoic acid and ethyl benzoate. This is all the same thing, same mechanism. Here also we have to use sodium bicarbonate. If you use the sodium bicarbonate, the benzoic acid, that is the benzoic acid, like what is that benzoic acid? That is COOH. This benzoic acid will give a brisk effervescence that confirms the presence of carbon dioxide. That is nothing but, so there will be a carboxylic acid present is there, that indicates. Okay. And next question is, give the chemical equation of HVZ reaction, that is a Hell-Volha-Zansky reaction. This was asked in the year of 2010 as well as 2010 Delhi board and All India board. So here nothing but alpha hydrogen containing carboxylic acid. This is a functional group, and nearby the functional group carbon. So we have one carbon that has hydrogen, that is what it has alpha hydrogen. This alpha hydrogen containing carboxylic acid reacts with red phosphorus and with chlorine or bromine like halogen. So if it is reacts with halogen to form its respective trihalides, the trihalides will able to involving in the ketone or tautomerism. After that intermediates, I'll be getting a product like that. What is that? CH2Cl COOH. That is the alpha halo carboxylic acid. Here if I use acetic acid here, alpha chloro acetic acid, I'll be getting as a product. If you don't know about this concept, please go and watch my previous video in HVZ reaction and its mechanism. That will be given in the iCard also. And here write the product of the following. This was asked in the year of 2013. So it is very simple one, I think. So here benzoic acid. So what kind of this is a functional group, am I right? So this is benzoic acid. Here COOH is a functional group. So here nothing but a bromination is going to take place. So what kind of product I'll be get? So I'll be getting a product like this. That is the same COOH is getting. But the thing is, in which position the bromine is going to come up? So the bromine is going to come up in meta position. Why it is coming to the meta position? So if you don't know about this concept, because these are all meta directing groups. Carboxylic acid is a meta directing group. So if you want to find out the ortho, para and meta directing groups, go and watch my previous video that will be given in iCard section also. Here check to find the functional groups and as well as ortho, para, meta directing groups. And next question, give the reason. That is a chloroacetic acid is more stronger than the acetic acid. This was asked in the year of 2013. Chloroacetic acid. So as we know that is a CH2Cl. This is called a chloro, and acetic acid COOH. This is a chloroacetic acid. And one more thing, CH3COOH is there. Okay. So here bond is there. And here also bond is there, but it can pull the electron. So as we know that the chlorine is a highly electronegative one, so which will tend to reduce the electron density on oxygen. If it reduces the electron density on oxygen, the leaving of H plus will become very easier in this case. But in this case, only electron donating group is there. That is what, which will not move very easily. That is what will be acting as a weak acid when compared to this one. So in this case, chloroacetic acid is more stronger. Why? This is because of that electron withdrawing group, or the highly electronegative one. So it's not electron withdrawing group. Here it is a highly electronegative one. So if it is a highly electronegative one, which can pull the electrons of this one. So if it pulls the electrons of this one, which will not able to maintain the electron density on oxygen. If oxygen is completely satisfied, which will not going to disturb this H plus. If it is deficient of electron, that time it will pull the electrons of hydrogen. So then the H plus will leave very easily in this case. That is what it will be very stronger acid when compared to this one. And next one is convert the following, that is acetic acid to ethanamine. So methanamine. So here acetic acid. So here in reactant side we have 2 carbon atom, but the product side we have only 1 carbon atom. That is what we have to move. So if you want to reduce one number of carbon atom, we have to do some Hofmann bromide degradation reaction. If you want to do the Hofmann bromide degradation reaction, that must be an amide. Okay, if you want to convert this into amide, then we can do reduction of one more carbon atom. Let's check how to do this. So here CH3, C double bond O, OH is there. If it is react with ammonia, so here H, NH2 is there. So if it is reacted as water molecule, so that time I'll be getting a product what kind of product? That is CH3, salt is there because it's a base, it's an acid, so there will be elimination of water molecule, so I'll be getting a salt as a product, that is a amide. So yeah, here I got an amide. So once I got an amide, after that I have to do one carbon atom reduction, that is sodium hydroxide as well as bromine. If I use these, this is called as a Hofmann degradation reaction. By that way, the C double bond is getting, group is getting eliminated. By that way, I will be getting a product CH3NH2 as a product. Are you able to understand? That is what my ultimate aim, that is what is that? Methanamine is my product. I think so you understand well. Thank you so much for watching. Please go forward to others to get benefit. Don't forget to subscribe my channel. Thank you so much for watching. Thank you once again. Thank you.
Thank you for learning. Share and like this video.